So I finished my game and it runs great in the browser on my Mac. The game is nothing fancy, so it should be a walk in a park to port it to Android. But when I ran it on my Android tablet for the first time, it ran like this. Clearly, I had some work left to do. In this video, I want to show you how you can analyze a performance problem, pinpoint the culprit, and fix it. I will be showing you how I used Unity's Profiler, Frame Debugger, and the Android GPU Inspector to identify the performance bottleneck and resolve it. Okay, let's get to it. The first thing we can do when we see a game running at this frame rate is to fire up Unity's Profiler. Before doing so, I want to refer you to a great video about how to use a profiler and about what CPU and GPU bound bottlenecks are. You should see a link to a video appear right around now. Alright, let's try and look at the Unity Profiler to figure out what the bottleneck is. So first, what we have to do is we have to make sure that we install a build that can be profiled. So let's first go to our build settings and make sure that development build is checked. You don't need to check this auto connect profiler or deprofiling support for this to work, so just leave them off for now. With these settings enabled, we can build and run our project. Okay, the app's now running on the tablet, so let's jump into the profiler. To open the profiler, we're going to go up to Window, Analysis, Profiler. First thing we have to do is we have to select our device. We can do that by going here to Play Mode and selecting our tablet. At that point, the profiling information should start coming in. What we can already see here is that we're consistently hitting 15 frames per second here up here in this area, which is unacceptable, right? And to now figure out exactly what's causing the app to render so slowly is first we can try to see which of these colored areas are actually contributing to the massive rendering time. In this case, it's this kind of green part, and the green part here is this rendering part. Yeah, so if we take that out, we can see that if we ignore rendering, we're actually rendering at 60 frames per second. So something in our rendering pipeline is causing this to slow down dramatically. And to figure out exactly what is causing that, we have to start looking down here in this timeline view here. Here we see the app basically divided up into multiple threads. We see the main thread, which runs our scripts, for instance. We see the render thread. Interesting for us is definitely the main thread. In a timeline of 80 milliseconds, we see that the vast majority of these 80 milliseconds were taken up by this part right here, this graphics wait for present on graphics thread. What this means is that our CPU wants to issue a graphics call to the GPU, but it can't because the GPU is still busy with its current workload. So the CPU can't issue any commands to it. That's what this wait for present on graphics thread means as far as I know. That means that something on the graphics card is taking so long that it's no longer able to take on any more work. So what we've identified here is a clear GPU bottleneck. Using Unity's Profiler, we have identified that we have a GPU-bound bottleneck. This means that an operation that is running on the GPU is taking up significant time and preventing the GPU from taking on any more work from the CPU. This results in the long wait for present on graphics thread bar in the Profiler timeline. However, the Profiler does not tell us what is actually happening on the GPU. So let's take a look at another tool in Unity's Profiler arsenal that gives us more insight into what is happening on the GPU. The Frame Debugger. The Frame Debugger allows us to step through all of the operations that the GPU performs to render a single frame. To open the Frame Debugger, we once again go to Window, Analysis, but this time we choose Frame Debugger. With our app running on the tablet, we first have to press this button Enable here. And then here, if not already selected, open this here, go to Remote, and select the app that you're profiling on your device. Once you do this, you can step through the individual steps that the GPU takes in order to render a single frame. You can do so by moving the scrubber here and step through all the steps kind of like in a quick fashion, or you can step through it kind of like you would in a traditional debugger. Now what's really neat here actually is if you look over here, this is a preview of what I see on my device. You can see that as I go through, you see the various rendering steps that the GPU is taking in order to present this frame. If we go all the way towards the end here, it starts to look more like the final thing that we see on a screen. So here, this is the final step, the UI and everything rendered on top. If we start to step back here a little bit, we see that the UI is layered on top of it, and then the panel, the title, the buttons, and so on. So this really allows you to drill into what the GPU is doing to render a single frame. This is incredibly fascinating on the one hand, and on the other hand, incredibly instructive. However, the one thing that's missing here is we don't actually know how long any of these steps are taking. So while this is really interesting and insightful, I still don't really know exactly where the bottleneck bottleneck is. I see, for instance, here that this bloom post-processing effect is doing a lot of dynamic drawing, but I don't know if that's actually that expensive. As far as I could find, Unity's profiling tools do not provide any way of learning about timing information of a game that targets Android. Instead, we have to look at the GPU profiling tools available for Android specifically. Luckily, there is a tool from Google called the Android GPU Inspector. The thing about GPU profiling is that the amount of info you can gather about what is happening on the GPU highly depends on the GPU that your device has. AGI's documentation lists the types of GPUs and devices that are supported, so be sure to have a look at that page if you want to know whether your device is supported. You can also just try your luck with your device. Before AGI profiles your GPU, it runs a brief validation step to ensure that the device is supported. If it passes that check, you should be good to go. If not, you might have to find other alternatives for profiling. If you're really unlucky, you might just have to make do with the Frame Debugger from Unity or work with CPU-bound profiling tools such as Unity's Profiler or something like Perfetto UI. In my case, my device is compatible with AGI, so let's have a look. Before you get started, it helps to prevent your device from going to sleep after longer periods of inactivity. Otherwise, your device might lock its screen and the profiler will no longer be able to retrieve information from it. Start by launching AGI. After the validation check succeeds, select the frame profile Vulkan in the type dropdown. Unless you have specified something explicitly in your Unity settings, Unity will likely export your game to use Vulkan on Android. Therefore, you should select this as your rendering backend in AGI as well. Fill in the remaining information and start profiling. Once the capture has completed, you can view the results. Initially, my results look like this. In other words, not all that helpful. Most of the interesting timing information was just missing. It turns out that profiling with Vulkan can lead to traces like this. To work around this, you can temporarily change the rendering backend of your Unity project to OpenGL, export your game again, and profile it using AGI again. Before you start profiling, be sure to select the OpenGL with angle frame profile in AGI. Once I did this, my report looked like this. All the timing information was there, and I could immediately spot a bottleneck. In my case, it was the rendering of the skybox that seemed to take almost 80 milliseconds. In my game, I use a custom shader to render the skybox. The shader creates this ethereal moving gradient. I never thought this would be so computationally expensive on a lower-end Android device, but here we are. Because I merely wanted to understand and validate whether that was really the biggest culprit for the slow performance, I just disabled my fancy skybox shader and ran the app again. And lo and behold, the frame rate is noticeably better. Still not where I want it to be, but I have made progress. To further smoothen it out, I could profile again and further isolate expensive operations. Before shipping my game and being 100% certain that I'd fixed the bottleneck, I have to change my Unity settings to what they were initially. That is, to export to Vulkan and not OpenGL. If and only if the game still runs smoothly on Vulkan have I actually fixed the bottleneck. A quick note here. Usually, if something takes a long time in OpenGL, it will take a long time in Vulkan as well, and vice versa. So the trick of switching to OpenGL for the sake of identifying a GPU bottleneck should probably be safe for a lot of cases. It at least can't hurt to try if you're stuck with limited profiling data on Vulkan. And that is basically it. By using Unity's profiler, I was able to determine whether the bottleneck was a CPU bottleneck or a GPU bottleneck. Using AGI, no, not artificial general intelligence, I was able to identify the culprit of my game's poor performance and fix it. I hope this video helps you if you're struggling with your game's frame rate. If you liked the video, don't forget to like it and subscribe to the channel for more content like this. See you next time.